For thousands of years, Betelgeuse has stood out as a brilliant red star on the shoulder of Orion. Its unusual color makes it easy to recognize, but its appearance hides something extraordinary. This is a massive red supergiant approaching the final stages of its stellar life. Unlike stars that seem almost unchanged from night to night, Betelgeuse naturally varies in brightness. It expands and contracts, while enormous regions of hot plasma rise and fall through its outer layers. And because the star is hundreds of light years away, every glimpse we get is actually a glimpse into the past. The light reaching Earth today began its journey from Betelgeuse centuries ago. That means astronomers are studying an older version of the star, not necessarily the way it exists at this exact moment. The scale of Betelgeuse is almost impossible to imagine. Its radius is hundreds of times greater than that of the Sun. If it were placed at the center of our solar system, its enormous outer layers would extend across the orbits of several inner planets and potentially much farther, depending on how its atmosphere is measured. But size is only part of the story. Betelgeuse is also an aging massive star. During its lifetime, nuclear fusion transformed lighter elements into heavier ones deep inside its interior. The star's structure became increasingly complicated, with different regions undergoing different stages of nuclear burning. Surrounding the interior are enormous convection cells. Hot material rises toward the surface while cooler material sinks back down. These structures are vastly larger than anything we experience on Earth, and some can occupy a substantial fraction of the star's visible surface. As these giant currents shift, different regions become brighter or darker. That helps explain why Betelgeuse can appear to change over time. But the star is also losing material. Powerful stellar winds carry gas away from its surface and into surrounding space. Over enormous periods, this material can form shells and clouds extending far beyond the visible star. Those outflows contain elements created during the star's evolution. Eventually, material released by dying stars can become part of the raw material used to form new stars and planets. In that sense, the death of a massive star is connected to the creation of future worlds. Then came one of the most dramatic episodes in recent observations of Betelgeuse. Between late 2019 and early 2020, the star became dramatically fainter. Its brightness fell to a fraction of its usual appearance, attracting attention from astronomers around the world. The timing was remarkable because Betelgeuse was already known to be an aging massive star. Naturally, people began asking an extraordinary question. Could the star finally be approaching its supernova? Observatories immediately began collecting more information. As measurements accumulated, however, the evidence pointed toward a different explanation. Betelgeuse had experienced a major eruption of material. A huge amount of gas was expelled from its surface. As that material traveled outward, it cooled and some of it condensed into dust. From Earth's viewpoint, the dust moved across part of the star's light and reduced its apparent brightness. At the same time, a cooler region appeared on the star's surface, making the change even more noticeable. So the dramatic dimming was not the beginning of a supernova. Instead, it gave astronomers something extremely valuable: a close look at how a massive red supergiant can lose material. The event also showed how dynamic Betelgeuse really is. Its outer atmosphere is not a smooth, calm shell. It is constantly changing, with enormous convection, powerful outflows, and shifting regions of temperature and brightness. Every new observation helps scientists improve their understanding of how massive stars evolve. But the biggest question remains. Betelgeuse will eventually reach the end of its life. And when that happens, the event will be far more dramatic than the Great Dimming. The future of Betelgeuse is written deep inside its core. As a massive star ages, it moves through increasingly advanced stages of nuclear fusion. Eventually, heavier and heavier elements accumulate toward the center. The process continues until the star reaches a critical stage involving iron. Iron is different from the lighter elements that powered the earlier stages of the star's life. Fusion involving iron no longer provides the energy needed to support the enormous weight pressing inward. At that point, the balance holding the star together can fail. Gravity suddenly gains the upper hand. The core collapses at an astonishing speed. Then, in a violent chain of events, the collapsing core produces an enormous stellar explosion. This is the type of event astronomers expect from a massive star like Betelgeuse, a core collapse supernova. For a short period, the explosion could transform the star's appearance in our sky. Betelgeuse could become dramatically brighter than it normally appears and remain visible for an extended period. The event would be spectacular, but according to the source scenario, its distance from Earth means it would not pose a direct threat to our planet. And that leaves one enormous mystery. When will it happen? That is something astronomers cannot predict precisely. The fact that Betelgeuse is nearing the end of its stellar evolution does not mean its explosion is scheduled for a particular year. It could happen much sooner than expected. Or it could happen thousands of years from now. There is even a fascinating consequence of the enormous distance between Betelgeuse and Earth. Because light takes hundreds of years to travel between the star and us, it is possible that the star's present-day condition is already different from what we see. The star could theoretically have undergone major changes that we will not observe until their light finally reaches Earth. In other words, the night sky contains delayed information. We are watching an ancient signal traveling through space. Until the next major change becomes visible, Betelgeuse will continue evolving. Its atmosphere will keep shifting. Its stellar winds will continue carrying material into space. Its enormous surface will remain a place of violent convection and changing temperatures. And the material it releases will eventually contribute to the larger cycle of cosmic evolution. This is one of the most remarkable aspects of massive stars. Their deaths do not simply erase them. The elements produced during their lives and expelled during their final stages can eventually become part of new generations of stars, planets, and other cosmic structures. The atoms around us have a history. Some were created inside stars that existed long before the Sun and Earth were born. So when Betelgeuse eventually reaches its final moment, its story will not truly end. Its explosion could spread newly processed material into the surrounding interstellar environment. Over enormous periods of time, that material could become part of future cosmic structures. The Great Dimming therefore becomes more than an interesting episode. It was a reminder that even a familiar star is constantly changing. What looked like a sudden disappearance of brightness revealed a complex interaction between the star's surface, its atmosphere, expelled material, and dust. And every observation adds another piece to the puzzle. Betelgeuse may be one of the most recognizable stars in our sky, but we still do not know exactly how its final chapter will unfold. That uncertainty is what makes it so fascinating. We know the star is massive. We know it is evolving. We know that someday its core will no longer be able to support its enormous weight. But the exact timing remains hidden. Perhaps that is the greatest lesson Betelgeuse offers us. The universe operates on timescales far beyond human lives. A star can spend millions of years evolving while humanity watches for only a few generations. We see only brief snapshots of a much longer story. And somewhere beyond the darkness of Orion, that story is still unfolding. One day, the red beacon we know as Betelgeuse will change forever. Until then, astronomers will continue watching, measuring, and waiting for the next clue from one of the most extraordinary stars visible from